Hi students, welcome to the part 2 of our video series on the most important questions of correlation and regression. Okay, so let us move on to the first question, that is question number 11. We have covered our question number 1 to 10 in the part 1. This is from 11 to 30 will be covered in the second part. Okay, so question number 11. Here is the question 11. Okay, now here we have done this kind of question in the previous class also. Okay, so assume that 69 and 112 are the mean values of x and y respectively. Assume that 69 and 112 are the mean values of x and y respectively. We are given these values sigma dx square, as if the table has been created and all the sum values are there at the bottom. Okay, so that is what we have here. Okay, this is dx into dy and n is equal to 8. Okay, this is the how the deviations have been found out. Dx will be equal to x minus 69. Here we are talking about correlation coefficient. We need to find the value of correlation coefficient r. Okay, so correlation coefficient is not affected by change in origin. Okay, here every observation is subtracted. From every observation 69 has been subtracted, and from every observation of y 112 has been subtracted. So actually it doesn't make any difference in the covariance correlation coefficient. Okay, so let us understand and try to find out the correlation coefficient r. We know the formula, that the formula is given by this one. Okay, so here we have the values, all the values here. Okay, so just put it into this this formula and calculate. Okay, r of xy will be equal to n into, what is n? N is equal to 8, capital or small. Here generally we have said it with a small one. Okay, so it is 8. Okay, so 8 into, what is sigma dx into dy? Sigma dx into dy is 2116. Okay, it is 2116. Okay, so this is into minus, what is sigma dx? Sigma dx is equal to 47 into sigma dy. Where is sigma dy? It is 108. Okay, 108 whole divided by square root of this is n into sigma dx square. That is when we put the values, this is whole divided by square root of n is equal to 8 into sigma d into x square. Okay, what is sigma dx square? Dx square is equal to 1475. It is 1475 minus something whole square, sigma dx whole square. What is sigma dx? 47. That is 47 whole square. Okay, into, we can take the whole thing in the same root also if you want. Okay, and put this into brackets. Okay, into n into, what is n? N is equal to 8 again. Sigma dy square is given to you as 3468 and then minus 108 whole square. Okay, sigma dy whole square. What is sigma dy? Sigma dy is 108. Okay, it is 108 whole square. Okay, when we calculate this thing using the calculator, what we get is 0.95. Okay, this is okay. Next question. Let us move on to the next question. Question 12. In rank correlation coefficient, the association need not be linear. Okay, whether it is true, false, partly true, and partly false. What can we say about this thing? We know that in rank correlation coefficient, the association need not be linear actually. Okay, because see, it is since it is based on the ranks rather than the actual observations. Okay, in Spearman's correlation coefficient, the association need not be, in finding Spearman's rank correlation, the association need not be linear. Okay, so since it is based on the ranks and not on actual observations, so it is true. Okay, next question, question number 13. Here the lines of regression are as follows. Okay, 5x minus 145 equal to this, and 14y minus 208 minus equal to minus 8x. What are the mean values of, what are the means? Okay, so here the solution of these two equations will be the means. Okay, so which one of these will satisfy this equation will be the mean, or we can solve these two equations. Okay, so this is 5x, this is 5x plus 10y equal to 145. I have rearranged this thing as ax plus by plus c, or ax plus by equal to c form. Okay, then this becomes 8x plus 14y equal to 208. So it is 8x plus 14y equal to 208. Okay, 208. Now this is equation number 1 and this is equation number 2. We can solve by substituting one into the other, or by making the coefficient of any one of the variables equal. Okay, here I am trying to make the coefficient of x equal and eliminate x. Okay, so 5 multiplied by 8 becomes 40. Okay, what I am doing, I am multiplying by 8, multiply by 8. What I get here is 40x plus 8 into 10 is 80y equal to, okay, 8 into 145. What is 8 into 145? 8 into 145 will be 1160. Okay, it will be 1160. Same way, this one will be multiplied by 5, multiplied by 5, and what we get here is 8 5s are 40x plus 14 5s are 70y will be equal to 208 into 5. 208 into 5 will be 1040. 1040. Okay, so when you solve this, subtract. Okay, so this will go. So we have 10y. 10y will be equal to 0 minus 0 is 0. 6 minus 4 is equal to 2, and this is 1. Okay, so y is equal to 12. We got y as 12. So y is 12 in 2 of these cases. Okay, so this is not the answer, this is not the answer. So one of these, which one? Okay, now we can take any one of the equations. We can take any one of the equations and put 7 or something into it as x and calculate. Okay, y is equal to 12. So take the first equation. In the first equation, what we have here is this is 5x plus 10y equal to 145. Actually, we can divide this thing by 5 to make it more simple. Okay, so this is 5x. We can have x plus 5 2s are 10, y equal to 5 2s are 10, 45, 29. Okay, so put y is equal to 12 here. So this is 12 into 2 plus x equal to 29. So x will be equal to 29 minus 24, and that is equal to 5. X is equal to 5. Okay, so we get x equal to 5. So 5 comma 12 is your correct answer. So x comma y, x bar comma y bar, x bar comma y bar will be equal to this. Okay, so the point where both the values meet, okay, the point where both the equations meet will be the means. Okay, this will be equal to 5 comma 12. Okay, x bar will be equal to 5 and y bar will be equal to 12. Okay, but we say that two regression lines meet at x bar comma y bar. Okay, this is the result that we should know, and that is being applied in this case. Okay, next question is question number 14. In question number 14, what we have? The coefficient of rank correlation of marks obtained by 10 students in English and economics was found to be 0.5. Okay, later discovered that the difference in the ranks in the two subjects obtained by one student was wrongly taken as 3 instead of 7. Here the correct coefficient of rank correlation is dash. So here again, see, we have a long method as well as a shortcut method. First, let us go with the long method and understand how to go across, and then we will understand how to do this problem in a short way, which will take say 5 seconds or so. Okay, so let us proceed further. So here it is question number 14. Okay, so in question number 14, what we have here is we need to find the rank correlation coefficient, or corrected coefficient of rank correlation. So first thing, the formula to find R. Okay, R correlation, rank correlation will be equal to 1 minus 6 into sigma di square divided by n square into n into n square minus 1. Okay, n into n square minus 1. Okay, so here the wrong are again something more. Later he discovered that the difference in the ranks, in the two subjects obtained by one student was wrongly taken as 3. Okay, the wrong difference dw was 3 and the correct difference was 7. Okay, the wrong difference was 3 and the correct difference was 7. Okay, now here we got wrong rank correlation, RR. Okay, this is the wrong RR and that is equal to 0.5. This is known to us. Okay, wrong rank correlation coefficient is given to us as 0.5. So it is 0.5 will be equal to 1 minus 6 into sigma di square. Sigma di square we don't know, that is again wrong sigma di square. Okay, divided by n into n square minus 1. That again is 10. N is equal to 10. Okay, n is equal to 10. So it is 10 into 10 square minus 1. This formula will give you the correct value. Okay, so therefore 6 into, I am taking here and there wrong value, wrong di square. Okay, divided by this is 10 into 99 will be equal to can I take this 0.5 this side? This has been taken that side, and 1 minus 0.5 will give you 0.5. Okay, now we shall move further. What is there? So here we have wrong di square equal to 0.5 into 990 divided by 6. Okay, so sum of wrong squares. Okay, what are we getting? Some wrong di square will be equal to 82.5. Okay, now we need to correct this. How to correct this? Correct the sum of squares. Correct sigma di square. Okay, not wrong. Here sigma should be there. Correct sigma di square will be equal to, what is this? This will be 82.5 minus or plus the correct one minus the wrong one. Okay, plus 7 square minus 3 square. Okay, that is equal to 82.5 plus 49 minus 9. Okay, 49 minus 10 is 40. So 82 plus 40. What is 82.5 plus 40? So 112, 14, 122. Okay, I think it is 122.5. Yes, 122.5. This is the correct sigma di square. So the correct value of rank correlation RR will be equal to, this is the correct rank correlation will be equal to 1 minus 6 into sigma di square. This di square is the correct one. Okay, divided by n into n square minus 1. Okay, so we shall put the values, and the values are this is 1 minus 6 into 122.5 divided by 990. Okay, we have calculated the same thing above, so we know how to do this. So using the calculator, what you get is 1 minus 0.74. It is 1 minus 0.74, which will be equal to 0.26. Okay, now let us go with the shortcut method. This is 0.26. Okay, so the answer is 0.26, option B. Option B is our answer. Okay, so you can see how much time it took to complete this thing in the traditional method. Now let us understand how to solve this in the shortcut method. Okay, now let us look at we know that this method is very long. Okay, so we have a shortcut method which will take you very less time to calculate. Okay, so let us look how to go with the shortcut. Okay, so this is the shortcut method. Okay, Just pay attention to the shortcut method. So observe, this is a trick, so you need to be careful with what we have and what we don't have. This is what we have. Okay, this is the data that we have. This is a wrong observation, a wrong deviation, so wrong di. Okay, wrong di will be 3, so square of 3 will be, first take the square of 3, that is the wrong di, that is, so that is 9 minus square of the correct di's, so that is 7 sevens are 49, then you multiply it by 6, you know there is a 6 in the formula, divided by n into n square minus 1, n into n square minus 1 will be, here in this case is 990, okay, and that will be equal to, sorry, to that you need to add 0.5, the actual value or the wrong value that you already had. Okay, you have to add it. Okay, so what we get, this is 40 minus 40 into 6 divided by 990, okay, plus 0.5. So let me calculate this thing. So when we calculate, what do we get? So it is say 40 into 6 into, sorry, divided by 990. Okay, so it is 24 point 0 point, what is it? It is equal to 0.24. Okay, minus 0.24, 24 and so on, plus 0.5. You need to add this. So to that I am adding 0.5. Okay, so what I get here is equal to, 0.2575 and so on. Okay, so what I am having here, this is 0.26. Okay, 26, which is same as this. Next, question number 15. Here what we have here is given the following data, bxy is given to you and byx is given to you. Coefficient of determination. See, this has not been discussed during the theory sessions, but you can just pay attention here that the coefficient of determination is nothing else but r square. Okay, coefficient of determination is equal to r square, where r is the correlation coefficient. So clearly what happens is r square is equal to, so the coefficient of determination, which is r square, will be defined as bx y into byx. Okay, so which is equal to the product of whatever these two values, 0.4 into 1.6, 16 fours is 64, it is 0.64. So your answer is 0.64, option D. Next question, question number 16. Okay, so here the method applied for deriving the regression equations is known as the method of concurrent deviation, the product moment method, or the normal equation, or the least squares method. Okay, it is the least squares method, the method of least squares. Next question, question number 17. Here what we have is the correlation coefficient between x and y series from the following data is to be found. Okay, we need to find out r. Okay, the number of pair of observations is 15. Arithmetic mean, this is x bar, this is y bar, this is sigma x, this is sigma y, and this is sum of squares of deviation from the mean. Okay, this is di square, sigma di square of x, sigma dx square, and this is sigma dy square. Okay, from their respective means. And the sum of products of deviations of x and y, sum of product of deviations of x and y series from the respective means, that is this is sigma dx into dy, sum of product of deviations from the respective means, and that is equal to 122. Now we need to find the coefficient of correlation. Very simple, we have the formula r is equal to covariance of x comma y divided by sigma x into sigma y, correct? So covariance of xy can be defined as sigma dx into dy divided by sigma dx into dy divided by n into Now what we have here is sigma x into sigma y. Sigma dx into dy. Sigma dx into dy is 122 divided by n into n was 15. What is sigma x? Sigma x is 3.01, and then what we have is sigma y, that is 3.03. When we calculate this thing, what do we get? 122 divided by it is 136 80. 136.80. Okay, further calculation will give you 0.89, and we have that here as option A. So option A is our correct answer. Okay, so here unnecessary values are given. This was not required to us, this was also not required to us. So let us move on to the next question, question number 18. So if the lines of regression in a bivariate distribution are given by x plus 2y equal to 5 and 2x plus 3y equal to 8, then what is the coefficient of correlation? So here we know that the coefficient of correlation R is equal to byx into bxy, correct? So this is regression coefficients byx and bxy. So let us suppose that the first one is the regression equation of y on x. So let y on x, and this is x on y. Okay, so let us distinguish these two things. Okay, y on x and x on y. So first equation was, this is x plus 2y equal to 5. The second equation is 2x plus 3y equal to 8. Okay, so from here we can isolate the y. Okay, isolate y, and y will be equal to minus 1 by 2x. Okay, or we can say that it is equal to minus x plus 5 by 2, minus 1 by 2 x plus 5 by 2. Okay, next, in this case we need to isolate the x. Okay, x will be equal to this is 3y minus 3y plus 8, here divided by 2. What we have is this one is called byx. Okay, if our assumption is correct that this one is y on x and this one is x on y, then we will satisfy the condition. Okay, this will be equal to minus 1 by 2, and this is bx comma y. Bxy will be equal to this item. Okay, that is minus 3 by 2. Now we know that the product, this is r square is equal to byx into bxy. Okay, so when we take this product, here both of them are negative, therefore correlation coefficient will also be negative. Okay, and the square should be less than 1, that is a condition. So we have byx is equal to minus 1 by 2 into this is minus 3 by 2. So what we have here is 3 ones are 3 by 4. Okay, so r square, this is r square which is less than 1, so the condition is satisfied. Okay, so we can get r is equal to plus or minus root of 3 by 4. Okay, but here both the regression coefficients are negative, therefore the correlation coefficient will also be negative, minus of root of 3 by 4. Okay, this can be simplified as minus root 3 divided by 2, and this further simplified will give you minus of 0.866 and so on. Okay, so it is option A, 0.866. Okay, so to find the regression coefficient, here we know that r square is less than 1, therefore our assumption is correct. Otherwise we had to take it in the other way around. We will have to take the reciprocals of these two. Next question number 19. If the correlation coefficient between two variables is 1, then the two lines of regression are of what type? So it is a perfect correlation, perfect positive correlation. Perfect positive correlation, what happens? Then the two lines will coincide or will be coincident with each other. Okay. Next question. If the sum of squares of difference of rank is 50, sigma di square is equal to 50 and the number of items n is equal to 8. What is the value of rank correlation coefficient? Again, the same formula, rank correlation coefficient RR will be equal to 1 minus sigma 6 into sigma di square divided by n into n square minus 1. Okay, while practicing all the time, write the formula and practice. In the exam, you need not write the formula. So, this is equal to 1 minus 6 into sigma di square is given to you as 50. So, 50 divided by n into, what is n? N was 8 into 8 is 64 minus 1 is 63. Okay. So, let us calculate this thing further. This is 1 minus 6 into 50 divided by 8 into 63. So, what happens? Let us calculate. Let us calculate and get it as 0.1 minus 6 into 50. So, let me write down the final answer as 0.40. Okay. So, this is your rank correlation coefficient. Now, let us move on to the next question, question number 21. So, if coefficient of correlation between x and y is 0.46, find the coefficient of correlation between x and y by 2. See here, let us see that this is 1 here. Okay. So, change in scale u was, say let me take it as u is equal to x by 1 and v will be equal to v is equal to y by 2. We need to find the correlation coefficient of we need to find out the coefficient of correlation r of uv, right, and that will be equal to either r of xy or it will be equal to minus of r of xy. It will be equal to this thing if signs of both the scale factors are equal. Okay, if the scale factors here, this is C and this is D. Okay, or I think this is B and this is D. This is B and this is D. Okay, so if the scale factors have same sign, if both scale factors have same sign, we are interested only in the sign of the scale factors, not in the magnitude of the scale factor. Here it is 1, 1, both positive, so therefore it is this. Okay, so therefore r of uv will be equal to r of xy, which is equal to 0.46. So 0.46 option A will be your correct answer. Okay, if both the scale factors have the same sign, then the correlation coefficient remains the same, and if both of them have different sign, okay, both scale factors have different sign, then both the correlation coefficients will have different sign. That's it. Next question, question number 22. Given the regression equations, we are given two regression equations. Find the regression equation of y on x. So, let us consider the regression equation of y on x as the first one and the x on y as the second one. This is the regression equation of y on x. This is the regression equation of y on x and this is the regression equation of x on y. Okay, we shall assume that, and if we get the r square less than 1, then our assumption will be correct. Otherwise, we have to interchange them. That's it. Okay, so let us find out this. Okay, y on x. So y will be equal to 13 minus 3x. Okay, and here what we have is x is equal to 20 minus 5y, 20 minus 5y divided by 2. Okay, so here minus 3 will be the minus 3 and here minus 5 by 2. These are the two values. Okay, so what we have here is b of yx is equal to minus 3 and b of xy is equal to minus 5 by 2. Okay, minus 5 by 2. So if 1 is greater than 1, so let me see there is any issue or not. Let us multiply these two and then check what happens. Okay, so here what we get is byx into bxy. Okay, byx into bxy should be equal to r square, and that is equal to minus 3 into minus 5 by 2, which is equal to 5 3s are 15 by 2, clearly greater than 1. So this is not possible. R square should be less than or equal to 1. Okay, R square should be less than or equal to 1. So therefore, our assumption is wrong. Our assumption is wrong, and we have to find out the regression equation of y on x. So this is not y on x. This is not y on x. This is not y on x, and this is y on x. So this one is y on x. Okay, let us, this is 2x plus 5y equal to 20. So where is the answer? This is 2x plus 5y equal to 20. There is no option. Let me check. This is 2x plus 5y equal to 20. Option D will be your answer. Next question, question number 23. In question number 23, the coefficient of correlation is significant and the correlation exists if R is greater than 6 into PE. What is PE? PE is the probable error. Okay, PE is the probable error. So let us understand what it is. The probable error of a coefficient of correlation depends or helps us. The probable error of coefficient of correlation helps us in interpreting its value. Okay, it will help us in interpreting its value only. Okay, whether it is correct or wrong. Okay, so it is observed that the coefficient of correlation is significant and the correlation exists only when R is greater than or equal to 6 into PE. We have not discussed this in our previous theory part. So therefore, this question should be noted down as a property that R is greater than or equal to 6 into probable error. Okay, PE means it is probable error. How to calculate probable error and all these things we shall understand while the questions come across. Okay, so question number 24. Two regression equations are given to you. Find the value of y if x is equal to 9. Okay, that is, we need to find or identify the regression coefficient of x on y, y on x, and put value of x into that. First, let us consider 2x plus 3y plus 18 equal to 0 as the regression equation of y on x, and let us consider x plus 2y minus 25 equal to 0 as the regression equation of x on y. Okay, for x on y, and this is for y on x. So therefore, what will be the coefficient of regression, or regression coefficient of y on x? Regression coefficient of y on x will be given by say, see, look here, this is a shortcut. B of yx will be given by, see, coefficient of x minus coefficient of x divided by coefficient of y. Okay, byx will be given as minus coefficient of x minus 2 by 3, and same way here bxy can be given as minus coefficient of minus coefficient of y divided by coefficient of x, minus coefficient of y divided by coefficient of x. Okay, now let us multiply these two things and check which one is correct or not. Okay, let us check. When we multiply these two, we get byx into bxy, which is equal to r square, and that will be equal to minus 2 by 3 into minus 2 by 1. Okay, so this is 2 2s are 4, minus minus plus, this is 4 by 3, this is greater than 1. Our assumption is wrong. So therefore, which is y on x? This one is y on x. This one is y on x. So therefore our assumption is wrong. What is our assumption? That y on x is this and x on y is this. So we have to reshuffle this. Okay, so therefore we can say that x plus 2y minus 25 equal to 0 is the regression of y on x. Okay, regression equation of y on x. Now we need to put the value of x equal to 9 to find y. We shall put the value of x as 9 plus 2y minus 25 equal to 0. So therefore, what we have here is 2y will be equal to 25 minus 9, which is equal to 16 y 2. Okay, so y is equal to 8 to 16. So y is equal to 8. Okay, let me take, see, there was an error in the question. So let me take one of them as minus 8. So therefore, 8, option A, 8 will be the correct answer. Okay, that's it. Let us move on to the next question, question number 25. The correlation coefficient between x and y is given to you as minus 1 by 2. So what we have here is Rxy is equal to minus 1 by 2. Okay, correlation coefficient is negative. Therefore, both the regression coefficients should be negative. Correct? So this is positive, this is positive, this is positive. This should be your answer. Correct? So this is one way, but what if you have two of them as negative? Then the finding will become difficult. So let us use the relation r square, or r square will be equal to, r square is equal to bxy into byx. Okay, so let us put the value. R square is equal to 1 by 4 equal to, what is bxy? Bxy is equal to 1 by 8 minus 1 by 8 into, what is byx to be found? Byx is to be found. Okay, so this is byx is equal to minus of 8 by 4. So 4 2s are 8. So minus 2 is your correct answer again. Okay, so byx is equal to minus of 2. Okay, let us move on to the next question, question number 26. Okay, 26. Now let us look into question number 26. Okay, in question number 26, what we have here is the ranks of two characteristics. Okay, ranks of two characteristics by two judges are in reverse order. Ranks of two characteristics by two judges are in reverse order. Then find the value of Spearman's rank correlation coefficient. Okay, so there were two characteristics, and on that basis it was judged. For example, say marks of first characteristic may be marks of mathematics, and the other one was marks of statistics, and like that let us consider what judges gave. Okay, for 5 people, let me take 5 as an example. Let n be is equal to 5, and we shall have, say, judge x, rank by judge x will be equal to, say, 1 2 3 4 and 5, assume, and rank by judge y will be equal to, say, 5 4 3 2 1. This is given to us, right? The judges, the ranks given by the two judges are in reverse order. Okay, so then what is the Spearman's rank correlation coefficient? So we need to find out di. So di will be here is equal to minus of 4, this is minus of 2, this is 0, this is 4, this is, sorry, this is 2, and this is 4. Okay, so di square will be 16, here also it will be 16, this is 4, this 0, again 4. Okay, so what is the sum? Sum will be, okay, 16 to 20 plus 20 is equal to 40. This is sigma di square. Okay, sigma di square. Now rank correlation coefficient RR will be equal to 1 minus sigma di square into 6 divided by n into n square minus 1. Okay, we know this formula. Let us put the values. The values are 1 by 1 minus 6 into sigma di square is equal to 40 divided by n into n square minus 1, n into n square minus 1, that is equal to 5 into 5 square minus 1. Okay, so that is equal to 1 minus this is 6, 8 5 is 40, 5 into 8 is equal to 40. Okay, we shall just put it 6 into 8 divided by, this is 5 as a 25 minus 1. What is 25 minus 1? It is 24. Okay, 6 4s are 24, 4 2s are 8. Okay, so this is 1 minus 2, which is equal to minus of 1. So the answer is minus 1. So if we have, this is for any value of n. Okay, I have just for the sake of understanding took an example for n is equal to 5. In case if the ranks are in reverse order, exactly reverse order, then the Spearman's rank correlation coefficient will be minus 1. Okay, so next question, question number 27. Which of the following regression equations represent the regression line of y on x? We don't know the first one. Let us assume and find the value of r. If r is less than, r square is less than 1, we say whatever our assumption is there is correct. Otherwise, we will interchange our assumption. Okay, let the first one x be y on x. Okay, y on x, the regression equation of y on x be 7x plus 2y plus 15 equal to 0, and the regression equation of x on y be 2x plus 5y plus 10 equal to 0. So remember the shortcut. What is b of y over x? Okay, it is x by y. Okay, we will take it that way. Y by x will be taken as minus of coefficient of x. Coefficient of x is 7 divided by coefficient of y, that is 2. Okay, so here what we have, bxy will have a coefficient of y divided by coefficient of x with a negative sign. Coefficient of y is 5 divided by coefficient of x is 2. Okay, now let us check. This is r square. R square is equal to byx into b of xy. Okay, so that is equal to minus 7 by 2 into minus 5 by 2. Okay, this is 7 5s are 35 divided by 4. This is greater than 1. So this, our assumption is false. Okay, our assumption, we have assumed that let the regression equation of y on x is this and x on y is this. So our assumption is false. So we need to change our assumption. So the asked was, represent the regression equation of y on x is not this but this. Okay, that is 2x plus 5y plus 10 equal to 0. 2x plus 5y plus 10 equal to 0. This is the regression equation of y on x. Where is the answer? Yes, here option B. 2x plus 5y plus 10 equal to 0 is the answer. Okay, option B is your correct answer. Hope you have understood how to solve this type of problems. These type of problems will be there in the exam. At least one question can be expected. Question number 28. In question number 28, if the rank correlation coefficient between the marks of management and mathematics for a group of students is 0.6. Okay, here it is given that rank correlation is given as 0.6. I'll note it down. And the sum of squares of the difference in ranks, sigma di square, is equal to 66. Then what is the number of students in the group? Again, n is equal to question mark. Okay, so we know that rank correlation coefficient RR is equal to 1 minus 6 into sigma di square divided by n into n square minus 1. Okay, RR is equal to 0.6 equal to 1 minus 6 into what is sigma di square? Sigma di square is 66 divided by this is n into n cube minus n, or we can say that it is n into n square minus 1. Let me take it like that. Okay, so what we have here is, let us calculate this thing. So 6 into 66, okay, 6 into 66 will give you 396, and here we have 1 minus 0.6. 0.6 will be equal to 6 into 66 is 396 divided by n into n square minus 1. So this is 0.4 is equal to 396 divided by n into n square minus 1. Okay, so n into n square minus 1 will be equal to n into n square minus 1 will be equal to 396 divided by 0.4. Okay, so we shall further simplify this thing and we get it as 990. Okay, let us divide and check. Let me divide 396 by 0.4. 396 divided by 4 equal to 990. 990. Okay, that is equal to 990. This is n into n square minus 1. We are familiar with this thing. Okay, can we write this thing as 9 into, or can we write this thing as 99 into 10, or 10 into 99? Okay, I can write this thing as 10 into 10 square minus 1. So we can now compare that n is equal to 10. Okay, n will be equal to 10. Very simple. So this is again a typical problem you need to be familiar with. Okay, correlation coefficient between x and y will be negative when x and y are decreasing? No. When both of them are moving in the opposite direction, that is when x is increasing and y is decreasing, or when x is decreasing and y is increasing. Here in these four options, option B will be the most appropriate option. Question number 30 and the final question for our video of today. Question number 30 is the two regression lines are given to you like this. Find the values of byx and bxy. It is the same type of question. Let us assume the first one as y on x, the second one as x on y. Okay, so let us assume that 7x minus 3y minus 18 equal to 0 be the regression equation of y on x, and let us assume that this 4x minus y minus 11 equal to 0 with the regression equation of x on y. Okay, correct. So therefore what will be byx? What will be bxy? We have studied that byx will be equal to minus coefficient of x divided by coefficient of y. Okay, for y on x. Okay, minus coefficient of x divided by coefficient of y, minus 7 by minus 3, which is equal to 7 by 3. In bxy, what we have here is minus of y by x. Coefficient of y is minus 1 divided by 4. Okay, so this is again 1 by 4. Both of them are positive. Now when we multiply, what we get? Byx into bxy is equal to 7 by 3 into 1 by 4. So what we have here is 7 by 4 3s are 12. Okay, 7 by 12. Yes, less than 1. Okay, so therefore our assumption is correct. So byx is equal to 7 by 3 and bxy is equal to 1 by 4. So option A is our correct answer. Okay, byx is equal to 7 by 3 and bxy is equal to 1 by 4 is our correct answer. So that's all for today. We shall meet in the next video. Thank you.